Welcome back. We're about to do some Algebra 1 stuff. We're going to solve by systems. Did we have a question before we get started about the math stuff? Or do we need to come back to it later? We'll come back to it later. I want to thank everybody that's subscribing. If you haven't subscribed yet, go ahead, hit the subscribe, hit the bell, hit the like, all that stuff. Just, this, that, and other. All right. Oh, you still can't see anything. I just forgot. So this is awesome. This is great. All right. I love when this happens in class. All right. So everybody gets the full experience just like if you were in my class. All right. So when we're solving by substitution, this right here is very important. I wonder why somebody capitalized every letter, made it bold, and put those little asterisks around it. Yeah, it's important. Yeah. Now, this is the second of the three methods that you have to solve systems of equations. So, this is when you will know you will absolutely use this. Some people use substitution for everything. They love this method. They will do whatever they need to use it. That's fine. Okay. So, what I've done is I've kind of written down what I would say if I wasn't even here. Okay. Here's our example. Here's our problems right here. This is our system. Okay. What is the variable by itself? What is the one where it's just one by itself, either the top or bottom? X. Okay. What is it equal to? All right. So what we do, now we know that X is 2y minus 7. We actually plug it in right here. Okay. So we would take that and plug this in, and now we only have one variable that we need to solve for. Okay. So we went from 2 down to 1. All right. Now, when we do this, we would have to distribute. Okay, so now we have 6y minus 21, and we leave this alone. All right. So all I did was distribute. Now, after you distribute, what do you need to do? Yeah, combine like terms. So we're going to combine 6 and 2. So what's 6 plus 2? 8. All right, and that's the only thing that we changed right here. All right. Now what do we need to do? Wait. I did. I totally wrote that wrong. I have no. Well, first thing we need to do is make sure that Mr. Jeffers writes it correctly and speaks correctly. All right. Now that I actually had the problem written correctly, see, other teachers would actually edit that out, but I ain't going to do that. This is, that's right. So, what are we going to do now? Yeah, you got to do the opposite of that negative 21. I knew where you were going. You just, it's early. It's early. Some of y'all's brains don't wake up to 3 p.m. any day. Anyways. All right, so now we have 8y equals 16. How do we solve that? Divide by 8. So now we get y equals 16. Okay. Now, something that we learned about the other day when we were doing the graphing is that these, yes, I'm sorry, it shouldn't be 16, it should be 2. I got excited. Thank you. All right. Now, something we learned about the other day when we were solving by graphing, we're actually going to have an x and a y. All right. So, what is the other variable? What is the other? What does the other variable equal? I can't even read my own typing. Yeah. How does it equal 1? What was the variable by itself? X. And what did it equal? 2y minus 7. But we now know what that y is. Yeah. Okay. So now we plug that in. All right. So what's 2 times 2? 4. What's 4 minus 7? Not just 3, -3. Now, there's our answer. So, yeah. So our total answer for this would be -3, 2. Okay. Yes, it is a long process. Okay. Even the graphing is a long process. Don't expect a whole bunch of stuff like 20 problems of this on the test. That would, no, there's no reason to do that. Okay. It does take a while. Now, what we have learned, when there are multiple steps, there's multiple what? Ways to solve it. There's also multiple ways that we can mess up. Yes. Hang on. I'm answering her first. What? Yeah, like where they would hit. Yeah, like what we did. All right. No. Oh, this part right here where y'all can't see because my face is there. Here, I'll do this. Now, so here's the deal. I'm going to say, like, solve by substitution. I'm going to actually, I'll probably have stuff like this for y'all to fill in on your test because that's part of the process. Okay. If you don't get the process right, you're not going to get the answer right. So I'm mainly grading the process of stuff. Okay. Um, I have seen students, they do such great math work, but they do something wrong at the very beginning and it screws up the whole problem. So instead of counting off 10 points for messing up on one step, I count off on that step. Okay. That's where we're getting at. I hear this every time we solve systems equations. It takes forever. Yes. But some of y'all, worked for 7 weeks to get onto Flappy Bird, that high level. All right. Thank you. Just grab a purple sheet and you can have a seat. Have a seat wherever I'll adjust it in the thing. All right, there you go. Now you got your seat. All right. So that's our first one. Are you supposed to understand everything we do after our first problem? No. Are we supposed to understand everything to do? No. That's why we keep going. Okay. So, all right. Let's look at example 2. What variable is by itself? Everybody, just shout it out. Yeah. Okay, so I heard X and Y. I don't know if they were being truthful or funny. Okay, all right. It's Y. Okay, so Y would go here. Shh. Yeah, I saw that. Yes, sir. Yes. Yes. No, no, wait. Say that again. If it's like this is by itself. Now, it could be written, this actually could be written like this. Yes. No, the reason why X is it by itself is because it has all this gobbledygook with it right here. All right, yeah. Well, Your realization is moving faster than my program to zoom in. That's amazing. Yeah, that's why X is not by itself. Okay, look around. We have people in our classroom that are sitting in a row or column by themselves. Okay, some people are not because they have stuff with them or people with them. I didn't mean to call y'all stuff. Sorry. All right. All right. So, what is Y equal to? Awesome. Okay. So now we have what variables by itself. Now we know what it's equal to. What do what do we do with this 3x minus 14? Yes. Now, yeah, we take out where the y was and we put the parentheses around it. And then we replace this stuff right here. So that's why we're substituting. Okay. Like, for instance, my dad is having to really work on his diet because of his heart condition. He's having to substitute decaffeinated coffee for regular coffee. Bless his heart. He is not loving it. One has caffeine. All right, my dad's coffee used to be so strong. After you drink a cup of it, you could smell colors. All right, it has more caffeine than like a Bang or something in it. Decaffeinated is like flavored water. Caffeine to decaf. Yeah, yeah. All right. Now, after we plug this in and we talk about Mr. Jeffrey's dad a little bit, what do we do now? No, we don't combine like terms first. Is what an arrow? Shh. Oh my gosh. Look, y'all just can't randomly shout out things. I don't process loud noises like that. All right. So now we distributed. Okay. Now what do we do? Yes. And our like terms is this. Now this is understood to be a 1. So what's 6 plus 1? Yes. All right. Now, how do we, what's our next step? Yeah. Yeah. We add 28 to both sides. All right. So now we have, and I'm just going to write over here because I like to do that. All right. So 14 plus 28 is 42. All right. Now, how do we get this x by itself? Shh. Listen. Yes, divide by 7. Y'all can easily say, Mr. Jeffries, you wrote the wrong number. Instead of going, what is that? Who? Y'all all do? Well, guess what? Listen, I had 2 bowls of Sassios. Y'all just need to calm down. That's because my class is awesome. All right. So now we know what 6 or x is. X is 6. We got that. Now, how do we find y? Yes. To where? Yes. So we have y equals 3x minus 14. Now we substitute in this value of x, which is 6. We get 18 minus 14, which is 4. Yes, I heard it somewhere. 4. All right. So our final answer is 6, 4. That's it. Now, yes, long process. Yeah, it's a long process when we're having to talk through each step, but after you get used to doing it, you'll actually start kind of going a little bit faster. I'm not going to say flying through it. I'm just going to say go a little bit faster. Okay, here. Hey, that I have a student in my second block. They actually do like a homework hotline thing when y'all have y'all's at-home test, and they work together and stuff. Oh, you've done that? That's awesome. That's that's great. Yeah. Now, all right, are we good with this? All right, now we've had two really good ones. Yeah, now we have this. Yes. You got a different answer? How? What 3 times 6 is? How'd you get 2? How's 42 divided by 7 2? You said 42 divided by 7 is 2. Yeah, we plugged in. We took this and then we solved for x. Yes, that's what y equals. That's how we eliminate this so we can solve it with one equation. No, x is 6. Because see how it says 7x right here? Yeah, it's okay. Oh, that's when you had the wrong thing. That's when you had the wrong thing right there. You got you got y equals 6 and you plugged it in here when it should be x equals 6. Yeah, you just had the wrong. You said y equals 6, but you plugged it in. Yeah, yeah, for x. Yeah. All right. What just happened? All right. What what just happened to my stuff? All right. There was example 2. All right. Example 3. Now, what if there's not a variable by itself? Now, we will learn another method Monday of how to deal with this, where if you didn't want to use substitution, you wouldn't have to. But if you're some of those students that you love substitution, that's the only method you want to use, I want you to be prepared. All right. Now, this is what we need to ask. Which variable do we want by itself? Okay. Now, here's the deal. There's two different variables. There are 20 plus of y'all. Not everybody's going to agree. No. Shh. Look, hey, y'all quit chasing rabbits. This is how people get lost. Okay? You have to look to see what do we want to do. Look, so let's kind of focus a little bit. That might be hard for some of y'all. All right. If we look at this top equation, come on, you can do it. Come on. There we go. All right. If we look at this top equation, would it be easier to get x or y by itself? Why? Because if we try to get x by itself, we got to end up dividing by a -5 later. Okay? So we could take the top one and solve for y. Or some people are going to look at the bottom equation and they're going to do what? Solve for x, because you could add 3y to both sides. It doesn't matter. Okay? Yeah, you're going to get the same answer no matter which one you do. Okay? Yes. On the top? Yes. then you're going to have some really weird fractions. Yeah, yes. The x always goes first. All right. So notice I said we. It doesn't matter. We could do either one. What do y'all want to get on one side by itself? All right, x. So we had a lot of people say x, or I heard a lot of people. I have one ear, and I heard two people say x. I'm sorry. If you didn't say something else, you didn't speak loud enough for once. Okay. So, so if we're wanting x by itself, what are we going to use? Are we going to use the top or the bottom? The bottom. We're going to use this to get x by itself. And how do we do that? Add 3y to both sides. Now, you can write it like this, or you could write it as 3y minus 23. It doesn't matter. Okay, when I tried to do that the other day on Tuesday, half people got confused. Yes. Yep. All right. So now we know what. Yes. Okay. What we were trying to do was get x by itself. So what we did is add 3y to both sides, which canceled the 3y on the left side. Then we cannot combine negative 23 and 3y, so we just write it like this. All right, good deal. Now we get to actually plug this in. So we're going to take this top equation, do parentheses where x used to be, and now we're going to plug in this. And then we're going to do the same process we have been doing. Okay, yeah, we're probably going to get a big number because we got 5 times 23 in there. It's okay. Big numbers are our friend because we all want to be really rich one day. You can't be really rich if you're scared of big numbers. Okay. All right. So is everybody to this point right here? Yes, no, maybe. Yes. Yes, you can write it 3y minus 23. That's fine. Okay. All right. Now we get to distribute. Negative 5 times negative 23, if you wrote it this way, would be what? 115. Very good. And this negative 5 times a positive 3 would give us a minus 15y. All right. So now we've gotten this far. All right. Now, what have we been doing all class after we after we distributed? Yes. Yes. What are our like terms? Not just 15y, not just 15y, negative 15y. Okay? Because that will mess some people up if you forget that. All right. So this actually becomes negative 14y. All right. Now what do we need to do? Yeah. It's what's the sign in front, not the sign behind. Yeah, that was the issue. A lot of people have that issue. They go with the sign behind. It's the one in front as we read from right to left. Okay, so let's see. 17 minus 115. Okay, we get negative 98. Now what do we do? Now, this is why on the stuff that I show you on Monday, this is why some people won't use this method for this because it can be a little bit easier. Yes. No. Wait, the final answer or what y equals? Okay, yes, please. Please say what? Huh? Not negative because it's negative divided by a negative, so it would be a positive 7. Remember 17 minus, yeah, no, it's positive. Okay, so we know what y is. How do we find x? We can plug it in. Where are we going to plug it in? Does it matter? Can we plug it in here? I know, but can we use the top equation? Can we use the bottom before we moved it over? Or can we use this one after we moved it over? Yeah, you can use either one. If you look, this is when you want to ask yourself, WWJD, what would Jeffries do? Okay. Jeffries is going to use, remember, that's me. Jeffries is going to use the easiest path. Okay. The other two problems we had a variable by itself. We found the other one, plugged it in, bam, got our answer. You can actually take this right here that we had and plug it in right here to get our answer. Okay. 3 times 7 is 21. 21 minus 23 is negative 2. So our final answer after all this is this. Now, this section right here. This is the stuff we're learning now. This is actually how I know how to set up the problems. So every problem you have is negative 1, 2. And I did that on like a little quiz one time. They only had 3 problems and they all the answers were negative 1, 2. And all the students freaked out. It was hilarious. I'm not going to do that to y'all. Yes. Huh? So you're saying that you used this right here? You did. And you plugged in 7. You got negative 21 here. And then you added 21. No. And you still got negative 2. Yeah, this is where I said you could actually use either the top or the bottom at the very beginning, or you could use the one where we had a variable by itself. It doesn't matter. Okay, you're going to get the same stuff. All right, you're going to get the same stuff. Now, for those listening at home, thank you for. I want to thank my subscribers. Also, want to thank if you want to subscribe, go ahead and hit the subscribe, hit the bell, hit the like button. Thank y'all again. My class right now are actually going to work on 3 problems. It may take them the rest of the time, and that's okay because I don't care. All right. So good stuff, good things. Roll Tide.